What's up, Grummies? Welcome to Arroyo Office Hours, your source for free cannabis cultivation education. I am your moderator, Kaisha. We are on episode 105. Shout out to all of our live viewers on the Hangout, on YouTube, and on Instagram, and to everyone tapping in on Spotify, Apple Music, YouTube, or wherever you listen to podcasts. Thank you for your support. If you like the pod, drop us a review. We appreciate the feedback. Seth and Jason, what's up, guys?
Hey, Kaisha.
How you doing?
Pretty good. We actually finally have some good weather here in the Northwest. I think it was over 70 when I went to lunch, which is pretty wild.
Snap. We might have to take the show outside one of these days. Amazing. All right. Well, who's in the studio with us today?
We got Jordan Zager, founder of Dewey Scientific here. Local grower, also a genetics pioneer in the cannabis industry. So we thought it'd be fun to bring him in and kind of talk about that journey a little bit, what it's been like to enter the cannabis market from the perspective of trying to, be a genetics company and what that journey has been like a little bit, I think it's pretty relatable and also unique in its own way. And there's some fun things to touch on.
Amazing. Jordan, welcome to the pod. How are you?
Hey, thanks, Kaisha. Thanks, Seth. I'm doing really well. Like Seth said, it's finally nice here in the Pacific Northwest. I think our hybrid greenhouse has been hitting DLIs in the low 40s. So when we see that, we are happy campers here.
Already talking our language.
Yep.
Jordan, tell us a little bit about yourself. What's your background?
Yeah, so like Seth mentioned, I'm the founder of Dewey Scientific. We also have a consumer brand here in Washington, Dewey Cannabis Company. But my background, I'm a biochemist by training. As part of my education, studied how terpenes are made in special cell structures in plants, such as trichomes. When I got started on that was sort of before cannabis research was really, at least in my field of vision. But started out investigating tomatoes, mint, various mint species, pine trees. These are other plants that make a lot of terpenes that we use industrially. So I was just sort of investigating how the plants are making this on a genetic and biochemical level. And then as I progressed through my scientific career, cannabis caught my attention. First off, as a user, I was sort of getting fed up with a lot of the, I'm going to just say it, the bro science that was on, Grass City and Roll It Up forums of what terpenes are and how they might interact with the body. Definitely, I am a staunch believer in the entourage effect. So as a scientist and a cannabis consumer was very drawn into, okay, how is cannabis making these unique compounds that sort of differentiate strains from one another? And how can we sort of turn our knowledge of terpenes into something that can benefit the cannabis industry? So that really led to the launch of Dewey Scientific. We were founded by 3 PhD scientists with the goal of producing cannabis genetics that satisfy, first off, the cultivator. Yields matter. The bottom line matters more than anything for those folks, but also have a product that sells well in the marketplace, that checks many boxes, whether it's bag appeal, unique aromas, potency, what have you. We've been pretty focused on that. Some of the early wins coming out of our genetics program, we were the first group to at least report on powdery mildew resistance and identified the gene responsible. We do think there's a couple different loci in cannabis, but we discovered one of them, and these genetic loci being responsible for powdery mildew resistance. And we've been very focused on breeding that into as many cultivars as possible. And then we take a very unique approach to breeding for aromas.
Yeah, part of the reason I wanted to bring Jordan onto this podcast was to talk a little bit about how, I don't want to say traditional, but basically, plant breeding theory is being applied to cannabis now, and we're starting to work on, breeding projects towards a certain goal, not so much just making some crosses, see what smells good, what doesn't, but, progressing and finding like, hey, for a lot of growers out there, powdery mildew resistance and botrytis resistance are huge. Aspergillus resistance, that'd be cool. That's usually more of an environmental problem. But when we look at like the rest of agriculture, we have a lot of time put into basically taking very specific genes, crossing them into a line and then back crossing. And one of the challenges I think that comes about is that process takes time. When Jordan's talking about, let's say, introducing a gene for powdery mildew resistance into a specific line, and I know you can come on to this a little more. We've got a lot of back crossing selection. There might be thousands of plants we go through to find that one that we were able to, introduce this one gene into. while still maintaining the characteristics that we want from that line and not necessarily like turning it into something that we didn't want to. So yeah, if you can speak to that a little bit, like how was that journey in finding, you know, this powdery mildew resistance gene, and what I think giving viewers an idea of like how long it actually does take to introduce that into a line.
Yeah, the discovery process was a little bit of happenstance, coincidental luck, and then a lot of sort of relying on the methods that we knew what to do because of our experience in other crops. But really, it was a really damp winter out in Pullman, the winter of 2018 to 2019. And we were operating in some older greenhouses, didn't quite have the environmental control that we needed. So we had huge humidity swings between day and night. Of course, you know, great breeding ground for powdery mildew to inoculate and colonize our plants. But we had this one lineage that just, it didn't matter how powdery the room got. This one variety just kept maintaining resistance. So our breeder, you know, made the crosses, made an initial F1 cross. We raised those progeny, and we saw segregating population. About a quarter of the new varieties were resistant. So at that point, we started doing a little bit of genotyping, genotype those original parents, genotype those progeny, and then just started looking for differences. What did that resistant parent have that the other parent didn't, and was there a good correlation? And luckily for us, we found that it's a homozygous heterozygous dominant trait. So you really just need one copy of that resistance gene to pass it on and be expressed in its progeny. So that whole process took us about 11 months to discovery. And then, over the last 3 years, we've really just been, working towards developing homozygous parents. So where each allele is powdery mildew resistant, and using that as breeding stock. So at this stage, at Dewey Cannabis, our commercial brand, we've got about 16 commercial varieties that we put into products. All of those harbor that PM1 allele. They are resistant. And then with our breeding program, really trying to get that resistance into as many aroma backgrounds as possible. Because as we've seen over the last, call it 3 to 4 years, rather than this, indica sativa hybrid classification, everyone is moving towards or has moved towards aroma classification for varieties, either in competitions like the Emerald Cup, and even at the retail level, you're starting to see shelf segregation by aroma class. So for us, it's having that wide array of aroma options for cultivators while guaranteeing that powdery mildew resistance remains.
Yeah, and it's
11 months to develop that is wild.
To discover. I was going to say that's step one. We're talking. We're 3 years later. It sometimes takes that many generations and that much selection to find. Luckily for this, we found Jordan and co found a dominant gene that they can actually work with. If we were talking about something that was recessive and we had to make a homozygous recessive cross to be able to achieve this, we might bump double the time.
Yeah, that's absolutely correct. I think had it not been a dominant mutation, discovery probably would have taken closer to 3 years than those 11 months. And then everything after that is, validating, or no, I shouldn't say validating, but after that is, can we more quickly develop a test rather than to detect powdery mildew resistance rather than, just throwing powdery mildew on plants. And so then that took a number of years, about 2 years, just to develop a quick PCR test, very similar to how we're testing for COVID. We can test for powdery mildew resistance with a quick PCR.
Oh, absolutely. I think one thing that's cool about where we live, if you don't have a nice greenhouse, which you guys start out with the little older ones that were, a little more compromised, you have a great screening ground. And then you guys have to ride this balance where you're not able to fully fund the company based off of just research, right? So you have to have Dewey Cannabis Co., a production brand. So there's a nice balance to run, because I know from years of doing, agronomic research and plant breeding research in greenhouses, that is one nice thing. We used to actually inoculate powdery mildew and how can we destroy these crops? You have to pull data on trying to maintain a healthy environment, and then how do we evaluate them from there, right? Which is an interesting challenge because some growers have great environments. You guys are a little more specialized in helping out the ones that don't, and you ostensibly have a nice environment now.
Yeah, that's right. So Seth had mentioned our older greenhouses. Yeah, our cultivation facilities sort of split between the old facility and the new facility. The old facility was previously used for breeding wheat. So they were definitely not purpose built for cannabis. I think they were built in 1999. We moved into those things in 2018. So yeah, just dialing an environment in there was next to impossible. So we've sort of approached cannabis cultivation of, oh man, there are huge issues that every cultivator must be dealing with, right? In retrospect, we were a little naive with that. It was because we were dealing with a big old retrofitted greenhouse complex. Since then, we've built more hybrid greenhouses. These are more of the semi-sealed, much better environmentally controlled structures that you're seeing throughout the West. But really, it's just that approach of, okay, you can't grow a good cannabis product if your environment is terrible. You also can't do it if your genetics can't really work with the environment that you have. So that was sort of our approach there. But at the end of the day, this is an agricultural business, and the bottom line matters in agriculture more than almost any other industry, right? Margins are super slim for wheat farmers, for soy farmers, and not to mention cannabis farmers. And like Seth said, we had to find ways to make money. When we launched cannabis, or Dewey Scientific, we needed, we were a service business. We were doing genetic work for folks. We were doing a lot of consulting, doing a lot of, what we call bioinformatics, but sort of the data analysis of gene sequencing data. And as 2020 and 2021 came around, our client base just started drying up. Margins compressed for West Coast cultivators. So did our client book. So we sort of asked ourselves, okay, what else can we do? How can we sustain our R&D program through what we have? And that was, we developed the consumer brand Dewey Cannabis Company. So at this stage, the brand's about 4 years old, and it's able to support our R&D process. We're currently not doing any client work any longer. So we are able to focus on genetics that sell in the marketplace, that impact a cultivator's bottom line like ourselves. And then we're looking at partners on the genetic side to, let's get these great cultivars, strains, whatever you want to call them, out into the market.
Yeah, and I think one of the big things to highlight, and I think that growers, and this is something that probably doesn't ever communicate to consumers, but when we're looking at developing a strain that is optimal for growers and gives us the nose, the yield, plant structure, the disease resistance, everything we want, I think it's really important to understand how much time that takes. Because one thing we're seeing across the country right now, and honestly across the world, is we're dealing with a lot of, we have a lot of F1 hybrid selection from that. And while you can yield some great moms out of that, we're not really necessarily looking at genetic stability or the ability to fix certain traits. And as a result, a lot of growers are having to go to extreme lengths for certain varieties. On this show, we've talked ad nauseum about, candies, and like lemon cherry gelato is a huge one on the West Coast that's notoriously kind of finicky, tough to get to yield. And really the dream is, to take some of these qualities of flower, qualities of terpenes, everything else like that, and, basically eventually package them into a plant that is more commercially viable. As growers, especially if you've cranked through a lot of strains, we've all seen some that, we like to say, don't play well with others. You can't grow them in the same room, which is a bummer. But ultimately, when we're looking at plant science and the optimal conditions for growing plants quickly and at a high yield rate and with high quality, we're looking at a similar set of conditions. So when we encounter, a specific plant that only performs outside of those conditions, the challenge becomes, okay, how can we take that special nose and special look, everything about it, and then translate that into a plant that actually grows nicely with our other plants and works into the production system. For so long in cannabis, we were looking at very, very niche boutique kind of grows where someone could say, hey, I'm growing this very special 11-week strain, and hey, I'm getting a premium for it. This all works out. And then these days, that's just becoming less and less of a viable business option. So as we make steps forward, companies like Dewey are really taking some of the first steps into bringing these, all of these genetics into the modern age and making them a commercially viable product. That's something you can take and grow in Washington, California, Maine, you name it, wherever. What are your challenges? Let's talk about what kind of resistances we need to deal with. Do you have, control issues? You can't get your VPD down or up. Like, we can look at all of these different things and say, okay, maybe we need to look at growing certain strains that are going to work for you. So, at the end of the process here, we're not throwing away 20 to 30% of our crop to powdery mildew or botrytis or something like that. Because as a grower, by the time you are looking at genetics that work in these types of situations, you already know that you've got a problem. If you're like in the Northwest, if you're in a greenhouse, there's, I've grown probably about 85 strains in this area. And pretty quickly you figure out the ones that you just cannot grow at certain times of the year because you lack control. But, we don't all have a couple million right away. Like, you guys were in that boat a few years ago where it's like, hey, we would love to have a state-of-the-art greenhouse. What we don't have is cash to make that happen tomorrow. What's more practical? I can look at my plant population and say, hey, I've got some plants that I can grow very well, grow easily. I'm going to work with those until maybe I build up enough cash to actually upgrade the facility. But that all takes time, and you have to have something to do in the meantime. And that's where I think disease-resistant genetics and also just reliable genetics really come into play, because I've run into a lot of strains over the years that, they're just not stable. We see a lot of somatic mutations in them. Cloning reliability is not good. And a lot of it's because, hey, we selected from an F1 cross and that was the end of the line. Never went any further. So we never really got to see what little secrets that cross held and where we can really, diversify and find something that works for us. And the bummer, as you can attest to, it might be 1 in 10,000. It might be 1 in 100,000 when we look at recombination rates. And that's where I think a lot of cannabis growers, especially commercially, need to look at going, okay, where am I sourcing these genetics? How honest are they about, not only lineage, but like, what filial generation is this? How did you select it? What were your criteria? Because, we see a lot of situations right now where we have breeders that are working, let's say, under what I'd call traditional growing systems, basically 1,000-watt HPS, super old school setup, which is great. But hey, they're selecting all of those plants to grow under those conditions. Sometimes that's really hard to translate. I'm sure you've seen it when you take something that let's say you got a cut from someone that was selected under HPS for like 10 generations or something, or several crosses. When you go to throw those into your greenhouse with modern LEDs and everything else, the spectrum's different. Usually, like with that old school HPS in many generations, we can count on a certain consistency. When you change all that up, that's where we see some plants like, hey, why am I getting like full blown hermaphroditic plants? Like, I'm getting pollen sacs, not late flower, little bananas, as we say. And sometimes that's the difference, is you've selected for something that hasn't even been identified yet.
Yeah, no, you're spot on there. One of the issues that we have dealt with, when we got started, we were, in mixed light greenhouses, but heavy on the HPS. We were growing in soil in 10-gallon cloth pots. Wasn't because we thought this was the way. It was, our initial grower, this is how he did things. He's a legacy grower. And this is what he did. So we leaned into that. And we do have a handful of genetics that we inherited from him, that when we made that transition into these, first off into cocoa, then under LED lights, and now, with our generative steering program and really boosting substrate ECs, some of these older strains that were definitely developed, in someone's basement, 10, 15, 20 years ago, they don't perform the way they used to, and not necessarily in a bad sense. We've had some varieties, all of a sudden we made this switch and they've got just that much sweeter of an aroma profile, or they yield just that much more now that they're in cocoa. But at the same time, some of these things in later flower, we have one strain in particular that we've used a lot to breed with. But early on, when we made the transition to the newer facility, right about day 40, every single cycle, bananas were coming out. We could not figure out why. We thought maybe it's just because it's old. But we did some experimentation. We played with substrate EC. That was one of the big ones we played with. And we found that plant won't develop those mid flower stamen and pollen parts. If we're keeping that substrate EC, under 6, which is, it makes it then tough to generatively steer if you're not getting that high salt stress in the early days of flower. So it's definitely, plays a huge role now in how we're selecting commercial varieties. We know the industry has moved far away from, big soil cloth pots, hand watering, even HPS lights these days. So it's about adapting to where we think things should go, and what is ultimately going to be the cannabis of 5-10 years from now. So making sure we've got the genetics that match those environments.
Yeah, I think one thing people really need to understand about this whole process is all of this is experimentally determined. So like when Jorda and Co. are working with this huge variety of different genetics, sure, they can genotype them, look at it and say, hey, we've found a few locations that are going to indicate a few things to us, but there's so much unknown in that whole, all those genetics that it takes a lot of plants to pull it out in a lot of time. So I think that's one thing that, gets a little missed in our current market, where we have a lot of hype around, let's say crossing runts with literally everything in my library and saying that all of this is now a candy now. While that can produce some cool results, it's not really long-term thinking. It's short-term for your business. And then, long-term looking like, hey, what is my capability? Like I work with a lot of clients that really love to do pheno hunts, want to do their own crossing, but then inevitably the conversation comes down to, hey, what you're looking for. If we start looking at like, hey, you're supposedly at F6 with this cross. Let's go look at some recombination rates. You might be looking for 1 in 10,000, dude. How long does it take you at your, 20 plants or so, or maybe, luckily you might have a whole bench, like 100 plants of searching can you actually do? And then compound that with like, hey, do you want to deal with popping seeds and changing up your production strategy that much? So for a lot of growers, once they kind of go through some of those pains and realize like, hey, it's actually kind of expensive to get to these results, and our business isn't crossing, it's or pheno hunting, because we send it all to distillate, but it turns into, you lose more money trying to package 50 different phenos than you would just pushing it to distillate. Once you get that point, I think there's kind of a realization like, hey, there might be more investment opportunity for us to approach this more like standard ag and work with some breeding companies and say, hey, what we're willing to do is you're going to give us a selection that we'll trial, and we'll take out that pheno hunting, crossing, and selection process. So like there's still ample opportunities for growers everywhere to participate in the breeding process. But I think it's really valuable to find a breeding company that you can work with that, number one, hopefully, especially if you're an established person that's been running this stuff for a while in a commercial setting, they're going to take you more seriously, which is huge because you have great feedback. If you've got a 2,000 to 10,000 square foot room and you say, hey, let's blow some stuff up, that's an insane research opportunity. And when you're working with someone, they can give you, they might have searched through 5,000 plants to get this one selection. So you are ostensibly way farther ahead by participating in these processes than, trying to bootstrap it and do it on your own. And we're just now hitting the point in, legal and commercial cannabis cultivation where you can actually work with people, draw up contracts and say, hey, I have this thing. I'd love for you guys to work with it. Like, let's say you do have something special. You can do paperwork about it and make agreements and say, hey, I'm giving you this. Here's our agreement about how you're allowed to use it, how not, what you're going to do with it. And then you can take advantage of some of those resources that really haven't been available in cannabis until recently. Like working with Jordan here, he can take so many different genetics, warehouse them essentially, build a library, and then he's one of the few growers that like has some optimized research space and that built into the business plan. Now, we're in Eastern Washington, not downtown LA or, any big metro area. So like, Jordan's here doing this. He probably could be somewhere down in California, potentially trying to blow up, on social media, blow up, as like a small celebrity. But the part of the price of being able to do this, economically and actually make it realistic is being outside of some of that expensive production space. Jordan's facility is surrounded by wheat fields. there's
our cost of electricity. I think we're the third lowest industrial rate in the country.
Yeah.
It's an eighth of what it would be if we were in Sonoma County or, like Santa Rosa. And that really enables us to be able to use some of our space for either these large F1 pheno hunts, like you mentioned, or, when we're making, stabilizing family if we're, couple fetal crosses deep and they're making a back cross to make sure that whatever trait we're trying to fix gets fixed. And then we can, make the riskier gamble of putting things into production space. But you're absolutely right. Like our cost of production here in Eastern Washington is very low relative to say downtown LA or, even the Bay Area.
Yeah. Or the East Coast.
Yeah, absolutely.
I've been amazed by I've actually been really amazed by some of the facilities I've seen go up on the East Coast, despite what I would consider very high financial barriers to meet. And like, some of that's investment, obviously. Some of it's also just better business planning, because we've seen how the market matures on the West Coast, and they're planning for that $1,300 pound price or $1,000 pound price right off the bat, rather than thinking they're going to get 3,000 or 4,000 coming in. But that's a price you pay. Like I said, you might have a whole different life if you live down in the Bay Area or something, but you probably wouldn't be able to do nearly as much work as you're doing.
Yeah, absolutely. Our approach to that, sure, we could chase hype. We could go partner with pick your metro area, go partner with the growers there. Ultimately, we want to have something, we say it all the time, like we want the proof to be in our pudding. We want our genetics to be the hype. We don't want it to be because we, partnered with some grower. And not only that, we approach this business and cannabis as if it were traditional horticulture, and sort of the genetic work that goes in there. Most consumers of raspberries don't think about the raspberry breeding process like cannabis consumers do. And so I'm not saying that's our goal is we don't want customers thinking about what genetics are. But we recognize like a lot of work needs to go into this for this to be something that is repeatable regardless of location, and B is going to withstand the call it the $1,300 pound, which man, I wish we were getting that in Washington. But what is going to enable compressed prices to still have an economically viable product, and for us it's genetic stability.
Jordan, I got a question for you. You have experience with cultivation. You came into this with a PhD, so you have an interesting mix of the traditional knowledge with the science. And I would love to hear a little bit more about your journey, especially with Dewey and incorporating Arroyo into your world. Like, what has that journey been like for you? Kind of getting that bro science a little bit minimized so that you can use actual science.
Yeah, so our journey with Arroyo, it began when we were still growing in big cloth pots. And I think Jason and Seth had been out to our facility and were like, what are you doing? There's so much better ways. And we're just like, hey, we're just doing what our grower wants to do. But we first got plugged in with Arroyo. We did some trials with rock wool, got to be able to see the control that you can actually have in a different substrate, but also by having the data at your fingertips. And as commercial cultivators, when we started really leaning into Arroyo, we saw our yields jump, depending on the month, but as high as 70% month over month, or same month, different year. But in essence, we're getting the same amount of external light for the most part, leading to a much, much larger yield. And it really is just having that data at your fingertips, being able to look at, what your baseline is on field capacity, look at the, dry back for a genetic over the first 22 hours, but being able to see that time and time again. And then what that has enabled us to do is like Seth had mentioned, like growing genetics that may not make sense, to get with genetics that do make sense. So what we've done is we've sort of classified things we grow commercially into their own little buckets. We grow those together on the same bench, and give them the same watering strategies. And so for the most part, we've got our I think, you guys like to use the term short and squatty. Maybe that's a Jason term. But these short internode distance plants, they're generally, they're not getting that high dryback. They're not necessarily getting a super high substrate EC either. On the other hand, or on the other side, you've got, your long internode plants that are generally can handle higher ECs. They're generally getting P2s much earlier in the cycle than these other genetics are. So really, it's enabled us to make smart economic decisions while still having the genetic diversity that our end consumers want.
Yeah, I wish we had a picture of one of your flower rooms right now, just because the height difference on some of the different strains is pretty epic. And what they've been able to do is really start looking at like, hey, what are the feeding habits of these plants? Like Jordan said, characterizing them. Here's ones that we consider possible to grow on the same irrigation valve. Here's ones we don't. And the other thing I think is really cool about it is when Jordan now, like you said, you're trying to do a lot of consulting, help people understand how to grow some of these genetics. And part of your company's goal is to make them easier to grow. But it's a lot easier when you can give them instructions. You're like, hey, here's exactly what I did. Here's all the data to back it up. And here's the end product. If you can copy this, and for a lot of growers, that's way easier said than done, obviously. But when you can give someone like time series data of a whole run and say, hey, look, here's where we maintained our environment. Here's what our temperature and humidity did the entire time. And it goes both ways. Like if you guys hadn't got the upgraded greenhouses, you could at least give someone like, hey, in these conditions, here's what we could do. Here's how you replicate this result. And I think that makes it so much easier for breeders and genetics companies in general to be able to translate like, hey, here's what's going on. And then also once you get it to other growers, they can at least look at that and understand the difference between like, hey, here's how your company grows and here's how we grow, because at different points in time, like you guys using a little larger pots. Okay, you can explain to someone, hey, man, look at your drybacks. Look at this water content. You're in a bigger pot. Or in a smaller pot a lot of times, right? Like you throw it to someone, they're growing just straight clone into 1 gallon cocoa. But you at least have the data to look at them and say, okay, so here's what you're doing that's going on. Here's what we do. Here's how to get this result. But also, hey, let's look at what you're doing and how can we optimize your results inside of this system? Because now we have the data to look at it rather than just like, hey, I ran that in a 1 gallon versus a 2 gallon and here was the result. We can accurately replicate like Jordan's results in a little bit, just under 2 gallons, like 1 3/4 or something. You guys fill pots, I think.
Yeah, that's right.
Yeah. So we can say, hey, yeah, this is growing up with a little bit big, a little more media, but hey, you're in a 1 gallon. Let's just flip it a little earlier. Let's keep it a little smaller and we'll maintain that same plant to pot size ratio and kind of take the mystery out of like, what does this strain like? What doesn't it like? Because the reality is there's subtle differences in all of these, but on this podcast, we always go back to like, hey, you've got basically, VPD is one really, really guiding rule, but we've got a pretty strict set of parameters that plants grow the best in and that are, not necessarily easily achievable, but definitely technologically achievable on a commercial growing, setup. So like when we have the data and we can just do basic math and translate like, hey, what do we have to do to replicate this despite a slightly different setup? It makes things a lot easier for the growers on the ground who are actually doing this. Cause like, for Dewey, eventually you want way more people to grow your genetics. That's the whole idea of putting all this work into that. If you guys just wanted to grow weed, you could absolutely do that there. You could source other genetics, but the whole goal is to develop something. You put in this work, you get a satisfying result, you get it out there and other people are happy with it. That's a huge part of the thing. And then also, for people like Jordan and I, genetics nerds, it's fun too. You gotta keep some passion alive, right? And for some people, the passion is, there's a lot of work that goes into growing and maintaining a good commercial system. I don't want to understate that, but for some people, that's enough fun. Once you start stacking on too many things in one spot, that's when you're starting to head for disaster potentially.
Yeah, no, I think you're exactly right, Seth. And you had mentioned sort of having this recipe, and that is really what we are aiming to do. If you have an IKEA table without that recipe or that instruction book, you're not going to end up with a table. Just like if you don't have the recipe book for
do a cake, whatever.
Yeah, for making a cake, or in this case, the grow recipe for strain Y. If you don't know the parameters of what is that higher end of substrate EC this plant can take, what is the higher parameters of what can you expect on drybacks, you're not going to end up with that same end use quality. And so when we're working with a plant that, you change the light spectrum slightly and all of a sudden you have a dramatically different terpene profile. Well, as a genetics company, if we're going to be selling clones to folks in Massachusetts where it's predominantly indoor and we don't have that right exact recipe, well, they're not going to end up with that end product that they thought they're getting. Now, of course, that is the reality of the cannabis industry today. And so we are just trying to foster in the era of more consistency for the end consumer while still protecting that bottom line of the farmer.
Jordan, you were talking earlier about the challenges of dialing in environmental parameters, but then also irrigation is so important. We obviously, sensors are the cornerstone of what we do here. And we get a lot of questions on office hours around irrigation. So I was wondering if you could talk a little bit about your irrigation strategy, especially when you're grouping certain genetics together, trying to have a consistency among similar traded plants. But yeah, I'd love to hear more about that.
Our overall irrigation strategy is very in line with call it the short recipe book that comes with Arroyo, right? We have our generative steering at the beginning of the flower time. And then, depending on the genetic, that generative steering time will, either be longer or shorter. But, for the most part, when does that EC really start to spike up, and then we can move over to vegetative steering to make sure all those new flower sites bulk up. And so that's really what we're doing is we're looking at benchmarks from variety to variety. How many days into the flower cycle until we're hitting a dry back of 10 to 12%, or some genetics, they're just not going to dry back more than 6 to 8. So those are sort of the benchmarks we look at, and then that's how we group things from a genetic standpoint. And other than that, our irrigation strategies are we use RO water, we use our custom mix of fertilizers, and from there, each irrigation valve is getting a slightly different treatment. All plants are getting the same input EC, but they are not necessarily getting the exact same FERT schedule. Some varieties need P2s all afternoon just to stay happy. Others are, they might get a couple of P2s, late into week 6 of flower, and that's it. So it really is just highly dependent.
Yeah, I think that's what's one fun thing to look at when you're growing all these different varieties in one spot with data is you can really start to look at what the different plants like, what they don't like. And then one thing that's fun about, working with Dewey is the whole goal is to make this as easy as possible, right? So there's kind of a strict set of parameters that hey, we're going to pull the lever on, for instance, how long we're going to go generative and irrigation. That's a small lever. We're not pulling the big lever is hey, we're going to run at 2.1 VPD this whole run, at 86 degrees because this one strain likes it. The whole goal is to evaluate what do these strains do and how do they perform in realistic production environments. And I think that's one of the, traditionally has been one of the biggest roadblocks to cannabis genetic development is just not having the space. And then, for me, for instance, when I do some pheno hunts, do some selections at home, it's all fun. But my basement's got a 15-degree diff every day just because the lights turn off. It's underground. It's 62 degrees year round if I'm not running heat. So that's not a good selection environment for trying to take something and saying, hey, this is a banger. I'm going to put it into full production at your facility. Cool, you could buy a cut from me and throw it into a big greenhouse and it might turn out terrible, even though I'm yielding 3.8 pounds of light and, 29% THC, 3 milligrams of terps. It could be amazing in that. Then I give it to Jordan. He's like, yeah, that's not going to work.
It's just not yielding. Yeah. And our approach to that, for the most part, I don't know if this is a unique in Washington thing, but cannabis industry sales just really slow down right after Thanksgiving. They don't really pick up until March. So what this enables us to do is take some of that commercial space and turn that into large, pheno hunts, just like anybody else is doing. This is not necessarily unique to us, but this is the only time we're really looking at these F1 crosses And so, each winter we're looking at about 5,000 different seeds, usually spread across 6 to 10 crosses. And from there, we sort of pick the winners out of those. So, if we're starting at 1,000, we're usually picking between 5 and 8 plants to move forward. We'll then go test those initial F1s in an indoor room. We do have indoor rooms at Dewey, just to compare, how did this look from seed versus clone in an indoor room. And then from there, we can then compare the indoor quality or the indoor metrics back into the hybrid greenhouse metrics. If they're close, well, then we know we've got something that can work in multiple environments, leading to that same end product. But it really is, test those F1s in a greenhouse when the stakes are low, move those over into the indoor rooms because we're running those all of the time. And then validate, how does it from indoor to outdoor to hybrid greenhouse?
Yeah, I think that really highlights how you have to build a business strategy around it. I think that is the hardest part. And depending on, your overhead, initial setup costs, all that, how many bills do you have to pay? How many investors do you have to pay off? Can you afford to take some of that time out of your regular production schedule to do this? Because just as Jordan said, 5-6 cross, 5,000 seeds, that's right on par for what you want to do to get results. And actually, like, you guys are probably wishing you had 10 times the greenhouse space. Quite frequently,
Absolutely. Yeah. More greenhouse space, the better.
Yeah. The amount of times that you guys run across a gene where you're like, hey, a little bit of math tells us this is like a 1 in 100,000 plant. Like it's actually pretty often.
Yeah.
When you're trying to do that recombination calculation, and like, that's just what it takes. So, I think it's definitely a unique challenge, but I think growers out there really, really need to realize, like, hey, and that's not to say that I haven't met other breeders that do have the business plan in space. I've just overwhelmingly met a lot that really want to have something unique. And I think we really are just getting to the point where you can work with a breeder and actually be like, hey, in greater agriculture, contract breeding is a thing where, a large company goes to a breeding company and says, this is what we want. And the breeding company says, okay, we're going to do a little bit of research on this. We'll talk to you in like 3 months. And then we're going to have an idea of like, hey, this is going to be a 5-year contract that's going to cost us this amount of money. Here's about the resources we think it'll take. And that's been a standard in greater agriculture and horticulture for a long time. And, we're just getting to that point in cannabis where that's possible. And also just hitting some of these bigger businesses, if you have 20 to 30,000 square feet in flower, and you can economize that and keep it rolling, you actually do have a revenue stream that would support your ability to work with another company and actually do that. Whereas, rewind the clock even 5 years, and 100,000 square foot facility was massive, insanely massive. 20,000 was still pretty damn big. And 10,000 was like, hey, that's the goal right now, right? We're just going to get 10 to 15,000 square feet and we'll be rich. And now business is stabilized. And I think, some of the more successful people that I talk to really just work that into their business model, whether it's like, one of the best things I've seen is just take a look at your revenue and say, we want at least $100,000 to just talk to people throughout a year. Like, we may not, listen to everything every consultant we talk to says, but let's invest some money into staying, current with the industry and talking to as many people as we possibly can who have seen as many facilities, because it's not totally easy if you're just a business owner to call up a bunch of other businesses and say, hey, let me come in there and copy what you're doing. That's not exactly there. And then on the genetic side, I've talked to a lot of people that they start out trying to do the pheno hunts and stuff. And then between the time and the effort and then the lack of results, because they're popping, at max, let's say 100 seeds at a time, they're just not getting what they want out of it. They talk to some other grower that says, hey, I got these seeds and like, look here's this amazing selection. And then they go pop 50 seeds and they don't find anything that's even close to that. And unfortunately, that's a reality. We're all conditioned to buying like 5, 10, 50 if you're wild seeds at a time, get the breeders packed. And that's just nowhere near enough to really see a good genetic variation.
Yeah. And I would say, our goal with our breeding program is, if you have a pack of 10 seeds, rather than 1 or 2 keepers, there's 7 or 8 keepers. And it really is, it's just this iterative process, making sure your breeding pedigrees are set up in a way that when you find a trait that you want, that you can pull it from your germplasm, and there's no guessing. You don't need that original Blue Dream to, pass on that haze, right? You just got to make sure that haze is fixed in whatever seed lot you have. And then when you breed, if the goal is you want something with that aroma profile, that terpenoline rich profile, that it is fixed in that seed lot, or at least 75% fixed.
Yeah.
So yeah, if you're pulling seeds from Dewey, hopefully there's a higher chance of success. You don't need to be popping the 5,000 that we do every winter, but,
I want to highlight too. I think some people think plant breeding is like this wild thing where we dump like pounds of seeds into a genetic sequencing machine. And like, that's how you get results. And like, no, really, like 5,000 plants to go out and try to find, like, hopefully you got recombination on 1 or 10 or whatever it is, but like, hopefully you got that trait. And it's all hopeful. And that's something that I think, I like to try to be more transparent about, and that's in any kind of scientific research, especially agriculture in general. All of this is determined experimentally.
Well, we have the incredible benefit of having 3 experts on the show today. Jason is here as well. How do you guys feel about getting into some viewer questions?
Yeah, let's do it.
Ready? Okay. We've gotten a couple on the Hangout. I'm going to start with those. We'll get to as many as we can. But our Gromy Seth dropped this question. They wrote, you've mentioned daytime, nighttime differential a few times on the show. And I'm wondering if you can give a little overview or general recommendation of when and how to use it to our advantage.
Go ahead, Jason.
Thanks, guys.
I was going to start a little bit with the goals of the plant and some of the genetic tendencies of it. Typically, kind of as a general recommendation, we like to just step it up about 5 degrees twice throughout the cycle. So early on, say first third of the cycle, when we're stacking, we'll go with almost 0 to 5 degree nighttime, daytime differential. The second third of the flower cycle will go about 5 degree differential, and towards the end we'll go to about a 10 degree differential. Now, if we have a plant that doesn't exhibit nearly as much anthocyanin as we're trying to, a lot of times we'll increase how long we're doing that nighttime, daytime differential, or even increase a little bit of how much we're doing that. So, typical tendencies are, when we increase our nighttime, daytime diff, we'll be increasing the amount of anthocyanin production. A lot of times it also increase the generative type of cueing that we're doing on the plant. So if it's a plant that's extremely, stretching, it's a tall plant, and we are trying to curb that, we might start with that nighttime, daytime differential earlier in the cycle as well.
Yeah, and one thing to highlight there, with the recommendations that Jason just said, these are general recommendations based on ambient room temp, because not just your Arroyo sensor, but any sensor hanging in your room, that's what it's going to read. So, to take the next step, you really want to go in and get some leaf temperatures, ideally get some average leaf temperatures and see what your room's doing, because we see, situations where you're growing in under HPS and we got a +4 differential compared to ambient air temperature. So like, let's say the room's at 75, plants are at 78, and with LEDs, the traditional rule is HPS plus LED minus, like what are your plants versus the ambient room temp. However, across hundreds of facilities across the country, we've seen about every example of where that can be exactly the opposite. So it's really important to go in there and actually get like what's going on with your actual plants and read them. Like all of these recommendations are based on that 1 to 2 millimeters around the plant surface.
Amazing, guys. Yeah.
If Jordan doesn't have anything to say here as well, there's also another variable that we can control in here when we're looking at nighttime, daytime differential, and that would be how quickly we ramp or decrease to that other temperature. Typical tendencies is the faster we ramp, the more generative that we're cueing that plant. And so, really kind of the goals here is let's try and probably not change it as quickly as we could, just because we don't want to induce some of those changes extremely fast. And so I really like to do ramping in general. I'll ramp anywhere from 30 minutes to 3 hours, depending on my goals with the plant.
Yeah, and I think Jordan could probably speak to dew point problems if we do try to, change that temperature too fast, especially in a greenhouse situation.
Yeah, it really, in a greenhouse situation, sure, you can control temperature pretty well. It's the humidity that's a little bit more difficult to control. And this is very important as nighttime temps, get colder. water falls out of the air that much easier. Think of a glass of, ice cold Coca-Cola. There is going to be condensation. That's what can happen in your greenhouse. And it really is just that, cold temperature hitting moist air. So yeah, I like Jason's suggestion, ramp it. We ramp our stuff over 90 minutes. And, just on that sort of schedule, you guys like to do it in 5 degree steps a couple times through flower. We hold pretty steady until about week 6, and then we get progressively colder at night as those plants mature off.
Yeah. And like for you guys, that's a good point too. We talk a lot about, not making that change too fast. So Jordan, for instance, in the winter here, like if you can do that in 90 minutes without any problems, that's a good example, because it might be 25 degrees outside, on your greenhouse roof. And in 90 minutes, you still don't necessarily have to pull curtains fully to avoid your plants getting rained on. So, what may seem like a big challenge sometimes is a pretty small programming task. And like one of the challenges is maybe sometimes getting a controller that can actually do that for you. A lot of the cheaper solutions on the market or older solutions just don't have any ramping, and they don't have the factory programming available to let you program that in.
Amazing, you guys. To our Gromy Seth, thank you for dropping that question in the chat. Good luck. Let us know if you have any follow-ups. We're going to keep it moving. We actually got a first-time Gromy dropping a question. Shout out to Chet on the Hangout. Chet, I'm going to read your first question. If you want to unmute and chime in, you're welcome to. I've been managing a facility for the past year now, and a few rooms have been producing small white immature seeds on us. They seem to not pop up in the other rooms while growing the same strains. We are growing in 6-inch Hugos under Fluent Spider 2i using Jax 321 on a direct inject fertigator. We are growing in double tiers and only have about 4 feet of grow height to work with. EC is 3.5, pH 5.7. Usually start a heavy defull around day 21 and try to get some big dry backs, and then to reduce stretch and promote pre-flowers a bit. The plants usually start in flower around 800 ppfd, and daily bump the lights up to 90 to 100%, which when the plants grow up to the LED bar 2 inches away, we're at 2700 ppfd. Again, because we're in a double tier setup with very limited headroom. All right, that's the background.
I mean, there's a few things I'd be looking at, number one, potentially, especially if you have Arroya, getting that time series EC, like Jordan was saying, some plants at high ECs will tend to throw stamens, start to pollinate the room. And sometimes that doesn't happen at a rate that's high enough to be immediately obvious. We might have a few buds throwing it. And then especially if that happens around week 6, that's when we're seeing those white hollow immature seeds towards the end. And I think, one of the keys there is like really track that and start to get in there and look for when those stamens happen. Number one. Number two, if you're getting 2700 ppfd at the light, you're probably really, really driving those plants really hard. I would expect that you actually have some small buds at the end of your tips of your branches right up close to those lights, and some potential bleaching. So, something to look at is like, hey, flipping a smaller plant, especially if you're in a Hugo, it might sound strange, but we're talking about transplanting a very, very small plant into a Hugo, basically seeing a root at the bottom of the block and flipping it, like, especially in a double tiered situation. You got to go with a small plant so it doesn't get huge, right? And then, if it's only one strain in one room, get the data, start looking at like, hey, we might have a feed problem with this particular room. Like, hey, it's the farthest away from the pump station, and we thought we were getting 2.8 on every other room, and now we're getting 1.4 feed EC on this room for some as yet to be determined problem. That's one thing to look at. So one thing I would do is definitely test your feed EC coming into the room. And then also try to identify like, hey, do we have some odd outside behavior going on in this room that none of our other rooms experience? Like, is it getting too cold, too hot, too low a humidity? You're not talking about mold, so it's probably not a high humidity situation, but really just document it and try to figure out. And then, at the end of the day, sometimes we look at like the lineage of that strain. And like we were talking earlier, a lot of our strains out there have been selected for 20, 30 years under HPS. You might be dealing with a reaction to the spectrum that makes that strain completely non-viable in your production system. If you have to bend your production system too far to be able to even get a plant to not herm out on you, hey, that's risking the rest of your crop. And it might be like, hey, what premium do we get on that strain that makes it worth it to keep growing with this risk? And if we do get a premium and we have to treat the room really, really weird in order to get it not to herm, if you can't monocrop it in its own room, it's probably still too much of a risk to the rest of your crop.
Yeah. And I would just, I think a couple of things you can test, go in there when it's dark, make sure you're not getting any inadvertent light leaks. And then, if it sounds like this is only happening in a couple of your rooms specifically, it could be other things like airflow. Stress will lead to herms. Now, of course, we want some level of stress to increase flower sites during that generative stage. But if your lights are putting off a lot of heat, putting off a lot of light, and there's not good circulation in these, call it 2 of your 8 rooms, you're going to have these little microclimates that can lead to some hermaphrodism. And that's sort of what it sounds like with these small, immature white seeds you're experiencing. Is it's probably like a little microclimate stress. That's what I'd look at.
Yeah, I think you got to remember, over the last 10,000 years, people have made this plant dioecious. The fact that it can herm tells us it's really not that special compared to other plants in terms of sex determinism. And with cannabis, it's not just XY. That's why you can have an XX plant still throw stamens. That genetic sexism is not stored on just one chromosome. In cannabis, it's actually several copies of the same gene, and what's the frequency that you have those copies on various chromosomes. So I think that's one important thing to remember when we're really bashing our head against some of these plants herming out. Like, you will encounter some that will herm almost no matter what. And hey, that's the reality. And sometimes, like, if I grew 10 pounds of it in my basement, wasn't as big of a deal as if I grew 300 pounds of it in a commercial room and then I had to deal with it, right?
Yeah, Chet actually just dropped in the chat. We do have a problem where a few times a week in the morning, the HVAC system starts throwing out hot air when it should be cooling. It lasts for about an hour and will be between 80 to 85 degrees.
I'll do it.
That'll do it.
Oh yeah, if your bud temp, especially later in flower, starts to go, mid flower on, starts to go above about 85, 86 degrees, we're going to see foxtailing and oftentimes bananas, just because that's the plant's response to being that really hot environment. It senses that it could die, essentially, if the plant had a brain. Therefore, it's going to try to reproduce, right? It's trying to go to seed every cycle. And we're just stopping that because we're people and we want the best flower to smoke.
All right. Yeah. So what I'm hearing in that diagnosis is we've got some crop registration that probably should be happening, checking some equipment out, and kind of comparing some results. Yeah.
Yeah. If we combine that morning hot air with being close enough to an LED to see 20 or 20 some hundred ppfd, 2700 ppfd. I mean, even at an LED, there's going to be quite a bit of temperature that close to the fixture. So, we might see leaf surface temps, bud temps that are substantial.
Yeah, in this situation, I wouldn't be surprised like 92 to 95 degrees on those top buds, right, Jason?
Amazing. Yeah, Chet writes, thank you so much. Appreciate you too, Chet. We have it on the list to get the HVAC fixed. Keep us posted. Good luck over there. And I'm going to move on to this question. We have a couple minutes left, but it really seems appropriate considering Jordan is all about those terpenes. Midnight Scarter posted on a recent well-known cannabis podcast I listened to, they mentioned bringing THC numbers up on the same cultivar run to run by using certain practices that were not given. In the legal market, unfortunately, THC lab results is one of the largest driving factors buyers look for when purchasing flower. What kind of practices can a cultivator implement in order to maximize THC in their final product? This does not include sprinkling keef onto dry flower before testing, LOL. All right, got some advice for Midnight's Gardener?
Yeah, what we've seen time and time again, potency comes down to genetics. You can't expect a Subaru to compete with a Ferrari in a 0 to 60 race. Well, maybe some Subarus, but not an Outback. First and foremost, genetics. There are some other tricks, definitely not as sneaky as throwing keef onto dry flower. Maybe you just want to dry that flower a little bit more. There's and generally in not even just in pharma, but in like the nutraceutical world, most of these compounds or these plant derived products, before they go to a testing lab, they're what's called lyophilized or freeze dried. So you're in essence, freezing everything, removing every bit of water that might be in there, that might be adding that weight. So the less background weight, the higher the percentage of THC is going to be in there. And then I have heard a couple things. It's mostly on the terpene side of things. But some growers have had success by adding, in essence, antioxidants into their feed. Things like things we might take as supplements like melatonin. So in essence, these things are, their chemical structure is very similar to the same thing that's in sunscreen. So it's sort of reducing the oxidative stress a little bit, as at least, with terpene biochemistry, and not all that different from cannabinoid biochemistry during its production, is these enzymes that are responsible for these chemical reactions that produce terpenes and cannabinoids. They have what's called an iron sulfur cluster at the center of these enzymes. And iron sulfur they are very, they like to exchange electrons incredibly easily. So when you have a high oxidative environment, those electrons want to get taken away. So if that core of that terpene enzyme is not intact, well, you're not going to get terpene production. I think the same theory can relate over into cannabinoids. But this is all just sort of anecdotal at this stage. I don't have any true proof points.
Jasmonic acid spraying, all that fun stuff.
Yeah, jasmonic acid. Although I think that'd get your license suspended in many states. So yeah, I don't want to mess with PGRs too much.
I think one of the big things is focusing on that biosynthetic pathway, right? Like THC is an end product of a lot of different reactions leading up to that point. So a lot of that has to do with plant maturity and working with the plant's life cycle. So like what Jordan's talking about is like, hey, where can we come in and offer like something that might help this process along? What a lot of growers are still doing that's very, very difficult to get past is, one of the biggest things I see is late nitrate application. They're going with a single mix all the way through flower. So some of their strains just do not want to finish. They're getting that nitrate push, which means like, hey, we harvested this plant at 8 weeks. The numbers look great, but I have 31% THCA and 0.1% THC. Two things. One, that's legally hemp. And if you grew that in California, go sell it in like Kentucky or something. Make some money. But number two, that's a sign that we didn't actually like end that biosynthesis pathway. So we're missing out not only on THC, but like on several other cannabinoids that genetic might be able to express that we didn't. So nailing, your nutrient composition and your nutrient plan, so you're not necessarily forcing that strain to do something to not express what you want it to express. Looking at like, here in Washington, I can only think of very few companies that sell like super lemon haze or really any hazes, because it's a 10 to 12 week strain usually. So that doesn't fit in their production cycle. So like in my experience, like trying to grow sour diesel here on the Palouse, 8 weeks wasn't enough. It never was great. We never even released it commercially because it wouldn't grow to satisfaction inside the time cycle that we had said, here's what we need to do to produce a crop. So there's a lot of factors in that maturity, but at the end, it's really focusing on like, hey, what is the amount of time and what are the inputs needed for this strain to actually complete that biosynthetic pathway? And, for different strains, some of them just will not play in our typical commercial production. We joke a lot about like GMO and MAC as being, two of the polar opposite ends, but it really is true. There's that much of a difference in some of these strains between what they're able to achieve in a given time span with given inputs. The cool thing for growers is, hey, if we look at the levers we pull, there's how long do we flower? How long do we stay in different irrigation strategies? What EC do we run it at? Do we have enough CO2? Do we have enough light? And are we maintaining pH with our irrigation strategies? And that sounds like a lot of things to keep in order, but there's some great techs out there that help you keep it in line. And usually, like if you're working with a fertilizer company, for instance, typically they're not going to give you bad recommendations. Start there.
Well, on top of this one, so I was at a really cool seminar that one of the speakers was actually talking about the effects of predation on terpene content, trichome production. And so actually how much you deleaf and when you deleaf can impact how much trichomes that you see on the plant. So as a natural defense, when predation is impacting the plant, it produces more trichomes in order to protect itself as a natural defense. So one of those that maybe we might not think a lot about when we're correlating our THC and terpene profiles to our cultivation records, but scientifically has shown an impact on the end result.
Great insights, you guys. And I mean, I'll just say this as a consumer. I look forward to more consumers understanding the greatness of terpenes, because that's really, it's all about that entourage effect, right?
Oh yeah.
All
At
right.
the end, we got to get away from the indica sativa labeling and get more awareness around like, hey, what chemical profiles actually do what, right?
Yeah.
And we have so much variety that like you actually can characterize things by, not just aroma, but like what unique cannabinoids do they have? Do they have a lot of CBG? Do they have a lot of CBN, THCV, like all these rare compounds? And I'll go back to it, without growers focusing on quality. And that's the tough thing with the market and having that high THC percentage, right? Like I always pick on California, but it's like the forefront of where I see a lot of like really high THCA, low THC weed, and the market's eating it up, which is, causing growers to go more and more down that route. Like, hey, we're going to industrialize this more and more. But if you really are focusing on quality at the end of the day, you still have to like do a lot of crop registration, look at the final product, and have the patience to say, hey, we're going to run a 3-month life cycle on these plants. We're going to do it the way we normally do it. And then we'll evaluate from there. And I think that's one of the hardest things for people to accept sometimes is that, hey, my 8-week cycle just will not finish this plant, or I have one main injection line for my whole facility, so I can't actually like pull back on the nitrate or lower my EC feed for this one room. So there's little challenges that, or big in that case, if you only have one feed line for your entire, flowering part of your facility, that are a limitation. And it's way better to recognize that and then start to, like I said, just do as much crop registration and start to work inside of that box, because it might not be something that you can afford to fix tomorrow.
Yeah. Yeah. Also, consumers, there's so much more of the plant than THC. So I will leave it like that on a high note. We went a little long today, but oh my gosh, what a great show. Jordan from Dewey Cannabis Company, thank you so much for joining us today. Really great to have you.
Hey, thanks,
And of course, absolutely. And of course, Seth, Jason, and producer Chris couldn't do this without you. Thank you so much for another great session. Thank you all for joining us for this week's Arroyo Office Hours. To learn more about Arroyo, book a demo at arroyo.io, and our team will show you the ins and outs of the ultimate cannabis cultivation platform. If you have any crop steering or cultivation questions you want us to cover, if we didn't get to it today, don't worry. Drop your question anytime in the Arroyo app. Email us at sales@arroyo.io. Send us a DM on Instagram, Facebook, LinkedIn. We want to hear from you. And if you're a fan of the pod, please leave us a review on Spotify, Apple Music, YouTube, or wherever you listen to your podcasts. We appreciate your feedback. And don't forget to subscribe to our YouTube channel so you never miss an episode. Thanks, y'all. See you at episode 106. Bye.